Hello guys, in today's video we are going to learn how to simplify square roots, and we are going to take a look at this in what I feel like is the easiest, quickest way possible to simplify square roots. But before we get into how to do it, let's talk about what a square root is. So a square root symbol generally looks like this, a lot like a division symbol, and sometimes students get confused, but it is not division, it is a square root. So you may have seen before square root of 16. Basically what you're doing is figuring out what number can you multiply times itself to get 16. And we could kind of go through 2 times 2, oh that's 4. Well, let's move up. 3 times 3, no, that's 9, that doesn't work. Let's move up. 4 times 4 is 16. So that means the square root of 16 is 4 because 4 times 4 is 16, all right? Since this came out to be a nice whole number, that means 16 is a perfect square. Perfect square is a number, when you take the square root, you get a nice whole number, okay? Nice round, no decimals, no fractions, right? So what we want to do, we really need a list of perfect squares. That's what you're looking for when you simplify square roots, or that's the way I do it. We need a list of perfect squares. And I'm going to show you how to make a list, and then you want to use this list every time. So let's start. 2 squared equals 4. That means 4 is a perfect square. That's on my list. Now you go up, you make another one. 3 squared, 9. So 9 is a perfect square. See, I'm making my list. My list is circled. 4 squared, 16. Therefore, 16 is a perfect square. 5 squared gives us 25. 25 is a perfect square. And you just keep going. Okay. So you can start to memorize this, or you can make a list every time you are doing these kind of problems. But you really want to have this information right there available to you. 64. Barely have enough room there. And let's just go up to 10. So we have 9 squared, 81. And then 10 squared is 100. Now you can go much further than this, but for now, I'm going to start here. This is my list of perfect squares. The numbers that are circled are my perfect squares. And then you have scratch work out in front. So now that we have this list, we're going to get into how to actually solve or simplify perfect squares, and that we'll use this list to help us do that. For the first example, we have the square root of 20. And you can see here they're giving us the hint to remove all the perfect squares, and that's exactly what I would do anyway. So what we want to do is rewrite this square root of 20, rewrite it with factors of 20 that might be on my square root list, my perfect square list. So I always start with the biggest possibility and work my way down. So remember, on our perfect square list, we had 4, 9, 16, 25. And I'm going to stop right there because 25 is bigger than 20. Okay, so that's too big. What we want to do is use this list and see if we can rewrite 20 using these numbers. Okay, well, let's think about it. Let's try 16. Can we multiply 16 by anything to get 20? Can we multiply? That's no, right? 20 divided by 16 doesn't give you a whole number, so that's not what we're going to use. Let's try 9. 9 times another whole number equal to 20? Or does 20 divided by 9 give you a whole number? And it doesn't, so 9 doesn't work. Okay, so we'll go to 4. Can we rewrite 20 as 4 times something? What number times 4 will give us 20? That's 5. We know 4 times 5 is 20, so let's rewrite our square root as 4 times 5. Okay, so since that's similar, that's equivalent, we can do that. 20 and 4 times 5, same thing. Okay, where did the 4 come from? The 4 came from the perfect square list. Okay, now that we have it rewritten, what we do now is take the square root of this 4 because it's a perfect square. And we remember that that will be 2 because 2 squared was 4. So when you take the square root of 4, you get 2. 2 comes outside of the symbol, 5 stays in. Okay, and I'm going to pop back over and show you where those numbers came from and why it's a 2 on the outside and 4 on the inside. So remember here from our perfect square list, 2 squared was equal to 4. So that means when you take the square root of 4, you get 2. And that's why that 2 came out and the 5 stayed in. So let's see how we did. We'll type 2, then use the square root symbol, and then 5. This is how you would submit your answer on Khan Academy, and we can check it. Okay. Let's do one more like that. We have the square root of 12. Unfortunately, I think this is going to use the same numbers, but you remember your list. I'm just going to write it down over here again. And it's more than this, but you don't need to go past your number in the inside. So since the inside number is 12, I can really stop right here. 16 is too big. So I could start with 9. Can I rewrite 12 as 9 times something? No, I can't. All right, can I rewrite 12 as 4 times something? Yes, that would be 4 times 3. Now, since the 4 worked, you take the square root of 4, which we know is 2. 2 comes out, 3 stays in. The 4 went away because you took the square root of it. Once you get that to a 2, it goes away, 3 stays inside. So 2, click square root 3. Okay, great. Let's do this one because this one doesn't require us to use a 4. So we have the square root of 72. Once again, we need to use our perfect square list that we wrote down, which is 4, 9, 16, 25, 36, 49, 64, 81. And I can stop because 81 is bigger than 72. And I'm going to start with the very next one, which would be 64. Can I do 64 times a whole number and get 72? And the answer is no. So I can drop down to 49. Can I do 49 times a whole number to get 72? So 49 doesn't work either. Let's go to 36. Well, 36 times a whole number equals 72. And that's yes. I mean, 36 works. I'm going to use it because 36 times 2 is 72. Oops, that should be a 6. Excuse me. So you want to take the square root of 36, which we know from our list is going to be 6, and keep the 2 on the inside. 6 radical 2. Okay, great. Let's look at some where you have to use variables and expressions as well. In this example, we have 42, a to the 4th, b to the 6th that we're taking the square root of. And our scratch work is going to be very similar. We're still going to use our perfect square list. And we will figure out what we can rewrite 42 as. That's going to stay the same. So let's go ahead and do that. We know we need a 4, 9, 16, 25, 36, and then the next one is 49, which is too big. So we'll stop here. So we want to know, can you multiply 36 times anything to get 42? And that's not going to give us a whole number. So we'll drop down 25. 25 times anything, will that give us 42? So now we'll look at 16 because 25 didn't work either. When we do 16, 42 divided by 16 to see if we get a whole number, that doesn't work either. Can we rewrite 42 as 9 times something? And that's not working. And what about 4? That doesn't work either. And so for this problem, we will leave the 42 there because we cannot take out a perfect square. So it stays the same. Now let's move on to the variables. What we want to do here is list those variables out. Because it said 4 A's, you want to actually write 4 A's and 6 B's. Okay, so how do you simplify them? You group them in pairs. You group them in pairs because it says square root. Square is going to be 2. So every time you see 2, you circle it. There's 1. There's 1. 2 B's, and they have to match, right? So 2 B's, 2 more B's, and 2 more B's. Now, you can take out anything that's circled, right? So there's 1 circle of A's, 1, and then there's 2 circle of A's. So I put squared, okay? That came out, that came out. Then I have a circle of B's. How many circles? 1, 2, 3 circle of B's. So I get a 3. And left hand side is 42. And that's how you would do simplifying square roots with variables and expressions. So I'm just going to show you here how to type the answer in. You press this button. Oops. Come on, get it together. And then you square root side 42. Okay. Please ask your questions in class about this. Have a great day.